Hello everyone, I'm Paul and today we're solving problem 3202, find the maximum length of valid subsequence 2. Here it says this is medium, but this is actually very tricky, or at least it was for me. And I don't know if you can solve this if you have never seen something like this. So here we will go step by step. If you haven't seen part 1 yet, I recommend you to go and watch that video first. It's in my channel. We are given an integer array nums and a positive integer k. And we need to return the longest valid subsequence. And this is the requirement for a valid subsequence. Let's say this is the input. In case you know what a subsequence is, if we remove this and this, for example, the remaining elements form a subsequence. And if we remove all of these, for example, these elements form a subsequence. And if we don't remove anything, we also have a subsequence. So we can get a subsequence by removing some or none of the elements in the array. Now, a valid subsequence is a subsequence in which this holds. For example, let's say we take 1, 4, 1, 4. So we have this subsequence. And now we are looking at this formula. We take the first two elements and the sum of 1 and 4 is 5. 5 multiplied by k is 2. So the result in this first case is 2. And we do the same here. The sum of these elements is also 5. Multiplied by 3 is 2. So the result here is 2. And the result here is also 2. Given that the result in every case is equal, this is a valid subsequence. And this happens to be the longest valid subsequence that we can get. And it has a length of 4, so we return 4. Now we can have different valid subsequences. For example, we have already seen this. The result for each pair was 2. But we can have these, for example, and 1 plus 3 is 4, and 4 multiplied by 3 is 1. And here we also have 4, as the sum for 3 and 1 multiplied by 3 is also 1. So this is also a valid subsequence. And if we look here, for example, 2 plus 1 is 3, multiplied by 3 is 0, and 2 plus 1 is 3, multiplied by 3 is also 0. So this is also a valid subsequence. Now what I want you to see here is that we can have valid subsequences in which the results are all 2, or which in the results are all 1, or in which the results are all 0. So we can have valid subsequences for every result from 0 up to k minus 1. So the strategy will be the following. We will check for every possible result from 0 to k minus 1, and at each step we will try to get this subsequence with the maximum length. So this is the first observation. The sum for every two adjacent numbers multiplied by k should be equal to some number in between 0 and k minus 1. So let's write this. The sum of two adjacent numbers multiplied by k should be equal to some value in x. And this is the same as this. Here we are using something called modular arithmetic, where we add modulo k to each side. So we have a modulo k and b modulo k modulo k. And this should be equal to some value here, some value in this range. So now we can solve for this and we get the following. We get b modulo k equals to x minus a modulo k multiplied by k. Remember, we are subtracting this from both sides. So now we can try a remainder from 0 to k minus 1 and check which is the best subsequence in which this equation holds. So the overall approach will be the following. We will iterate every number from 0 to k minus 1, and then we will check which is the largest subsequence in which this equation holds. So first we are at the first value. Let's say x is 0, and each time we iterate a new remainder, we have a new map. This includes every key from 0 up to k minus 1, and the result is initially 0. And now we are iterating numbers from left to right from index 0. And first we take the corresponding value, in this case 1, modulo k. In this case k is 3. And 1 modulo 3 is 1. So this one is this. And now we are looking for this in the map. So we are looking for 0, remember x is 0, minus a modulo k, which is this, 1, modulo k, k is here, 3. And minus 1 modulo k, modulo 3 in Python is 2. So we look map at 2, in this case the value for this is 0, and we add 1, and the resulting value here is what we add in map at 1. Now why are we adding 1? It's for this element. We are taking the best subsequence in which this element is value. Given that we have all zeros right now, we put in map at 1, 1. Now the I pointer is here, so we do 4 divided by 3, and this is 1. So now we are looking for this in the map, meaning 0 minus 1 modulo 3. And this is 2, so we need to put 0 plus 1 in map at 1. So map at 1 is already 1. And the maximum value for the largest subsequence is currently 1, so we'll replace the result with 1. And now the I pointer is here. We have a 2. 2 modulo 3 is 2. So we are looking for this in the map, meaning 0 minus 2 modulo 3. And minus 2 modulo 3 is 1. So we take this value, 1, map at 1 is 1, and we add 1 for the current number, and this is 2. And this 2 is the value we need to put in map at 2. So we replace this with 2. Given that 2 is greater than 1, we replace this with 2. And what this means is the following. If we take 4 and 2, the sum of these values is 6. And 6 modulo 3 is 0. And right now we are checking the results with 0. So what this means is the largest subsequence we have seen so far is this one, and it has a length of 2. That's why here we put 2. Next we are here and we do 3 modulo 3, this is 0. So we are looking for 0 minus 0 modulo 3. And this is 0. So we take 0 plus 1 and we put this in map at 0. Now we're here and 1 modulo 3 is 1. So we do 0 minus 1 modulo 3. And this is minus 1 modulo 3, meaning 2. So we take 2 plus 1 and we put this at map at 1. So this is now 3. So now the largest subsequence has a length of 3, so we replace this with 3. And what this means is we have this valid subsequence. If we take 1 and 2, the sum is 3. Modulo 3, the result is 0. If we take 2 and 1, the sum is 3. Modulo 3, the result is 0. And remember, x is currently 0, so this is fine. Now we are here and we do 4 modulo 3, and this is 1. And 0 minus 1 modulo 3, this is 2. So we take 2 plus 1 and we put that in map at 1. This is already a 3. So we don't have to change anything here. And what this means is we have this valid subsequence of length 3. If we do 4 plus 2, this is 6 modulo 3, 0. and 2 plus 4 is 6, modulo 3 is 0. So this subsequence is also valid. It has a length of 3. That's why we keep this as it is. So now we update I and we reach the end. And the maximum value so far is 3. So now we will say x is 1. Remember, we'll try every value from 0 to k minus 1. So now we're here and 1 modulo 3 is 1. So we do 1 minus 1 modulo 3. This is 0. So we take the value for map at 0. This is 0 plus 1. It's 1. And we put in map at 1, 1. So this is now 1. Now we are here, 4 modulo 3 is 1, so we are looking for 1 minus 1 modulo 3 again. This is 0, so we take 0 plus 1, meaning 1, and we put in map at 1, a 1. Now we are here, and 2 modulo 3 is 2, so we are looking for 1 minus 2 modulo 3, and this is minus 1 modulo 3, meaning 2. So we take 0 plus 1, meaning 1, and we put that in map at 2. So this is now 1. Now the I pointer is here, 3 modulo 3 is 0, so we are looking for 1 minus 0 modulo k, and k is 3, so we are looking for 1 here, and map at 1 is 1 plus 1, 2. So we put in map at 0, 2. Remember what this means is if we take this subsequence, 3 plus 1 is 4 modulo 3, it's 1, and x is 1. So this is a valid subsequence. It's not the subsequence with the largest length, but it's valid. Now we are here, 1 modulo 3 is 1, so we are looking for 1 minus 1 modulo 3, this is 0. So we take 2 plus 1, meaning 3, and we put that in map at 1. So this is now 3, meaning this is also a valid subsequence. Now we are here and 4 modulo 3 is 1, so we are looking for 1 minus 1 modulo 3, this is 0. So we take 2 plus 1, meaning 3, and we put 3 here. We already have a 3, so we continue. Remember what this means is this is a valid subsequence. 4 plus 3 is 7, modulo 3 it's 1, and 4 plus 3 is 7 again, modulo 3 it's 1. We are looking for results with 1, so that's why this is a valid subsequence, meaning 4, 3, 4 is a valid subsequence. Finally, x is 2, meaning k minus 1, and the map is this again. The I pointer is here again. The first value is 1 modulo 3, meaning 1. So we are looking for 2 minus 1 modulo k, meaning 3. So we are looking for 1 modulo 3, it's 1. And so we take the corresponding value for this key, meaning 0 plus 1 is 1. So we replace map at 1 with 1. So this is now 1. Now the I pointer is here, 4 modulo 3 is 1, so we are looking for 2 minus 1 modulo 3 again, and this is 1, so we take map at 1 plus 1, meaning 2, and we put 2 in map at 1, so we replace this with 2. Remember what this means is this is a valid subsequence. 1 plus 4 is 5, modulo 3 it's 2. Right now we are looking for results with 2, so this is okay. Now the I pointer is here and 2 modulo 3 is 2. So we are looking for 2 minus 2 modulo 3 in the map. So we are looking for map at 0. And map at 0 is 0 plus 1 is 1. So we need to put in map at 2 a 1. Now we are here, 3 modulo 3 is 0, so we are looking for 2 minus 0 modulo 3, and this is 2. Map at 2 is 1 plus 1 is 2, so we need to replace map at 0 with a 2, meaning this is a valid subsequence. Now we're here, 1 modulo 3 is 1, so we are looking for 2 minus 1 modulo 3, and this is 1. So we take 2 plus 1, meaning 3, so we put in map at 1, a 3. So we replace this with 3. Remember what this means is this is a valid subsequence. 1 plus 4 is 5, modulo 3 is 2, which is our target, and 4 plus 1 is 5, modulo 3 is also 2. Finally, we are here, 4 modulo 3 is 1, so we are looking for 2 minus 1 modulo 3 in the map, meaning we are looking for 1. Map at 1 is 3, plus 1 is 4. So we put in map at 1 a 4. We replace this with 4, meaning this is a valid subsequence. It has a length of 4, that's why here we have a 4, and now we need to replace the result with 4. Now we update the I-pointer, we reach the end. K is already k minus 1, so we reach the end here too, and we return the result, which is 4. I know this might be very tricky, but this is sort of like a dynamic programming. We are keeping track of previous results, and every time we are trying to extend subsequences with the current value. For example, when we are here, we are trying to extend the best subsequence according to this formula. So we have a subsequence which ends with this. When we are here, it's this one, and we are taking the length for that subsequence and we are adding 1, and we are adding 1 for the current element. So we are repeating the same again and again, and we are keeping the maximum value. So now let's go with the code, and hopefully you will get the idea. The code for this is very short. First, the result is 0, and we will return this. And here in between, we need to iterate every x, meaning every remainder, every value from 0 to k minus 1. So for x in range k, first we create a map, so we'll create a default dictionary, and this will take a default value of 0 for every key. And now we will iterate numbers, so for every num in nums, first we do num modulo equal k, and now we will say map at num equals the formula, so meaning the corresponding value in the map for the formula. So map at x minus num modulo k plus 1 for the current number, and each time we are checking if this is the maximum value, so result is the maximum among the result, and map at num. Now remember, here we need to do a plus b modulo k, this equals to x, and this is the same as saying a modulo k plus b modulo k modulo k equals x. And now we can solve for b modulo k, so b modulo k equals x minus a modulo k again. So now what we are doing here is to extend a subsequence with current num. We need to take the count of the best subsequence that ends with x minus num modulo k and add 1. Remember, we add 1 for the current element. So this is the entire code and the entire idea. Now let's submit this and see if it works. As you can see, this works, this is efficient, and this is just tricky, or at least for me this was not easy. If you didn't get the idea, I recommend you to watch this again, and if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.